On the most recent Core 3 test in with my A2 class, my Year 13 class, there were 3 different types of questions on there. There was an exponential functions question, there were 2 Simpsons Rule questions, and then there was a volumes of revolution question. So I'm going to split those up into 3 different videos so that you only have to watch what you want to watch if you need help on this. So there's lots of different ways that you can do Simpsons Rule, and it's up to you to find the method that you prefer. So you look around in different texts or look around on the internet for different versions, the one that you use that makes fewest mistakes. I'm going to show you the way that I prefer to do it, and that might be the way that you like. So don't forget, Simpsons Rule is on your green formula book that you're given at the beginning of the exam. Don't get it confused with the trapezium rule which you learn for your AS. You must use Simpsons Rule when you're asked to use Simpsons Rule. And if you're retaking Core 2, you're not allowed to use Simpsons Rule when they ask you to do the trapezium rule. Okay, so let's get on with it. I'm not going to write it down in full here because you can, it's on your booklet and you can look it up. But the first thing we need to do is to work out the values of x that we're going to put in. And we know it's x because the variable's x and we're integrating with respect to x. So we've got to find the 5, in this case 5 values of x that we're going to substitute into our estimated answer, sorry. Now, we've got to find 5 ordinates. Now there's 2 ways that they could ask you to do an approximate answer, an estimate of the answer, and that's by either defining ordinates or by defining intervals. Now remember, there's always one more ordinate than intervals. So if you look at this, in this particular diagram here, this region between 0 and 1 has been split up into 4 intervals using 5 ordinates because it includes the 0. The 0 is included. Now you can see from here it's quite straightforward. It's going to be a half, a quarter and 3/4. So our ordinates, and remember ordinates are values on one axis or one number line in this case, because a coordinate is a pair of ordinates and that gives us a point on a 2-dimensional reference frame or graph. So anyway, back to the Simpsons Rule. So we've got the values when x equals 0, x equals quarter, x equals half, and so on. Now the way I suggest you do it is that first of all you collect together the ends, so x equals 0 and x equals 1, and so that's going to be tan to the minus 1 of 0 and tan to the minus 1 of 1, and these are the ends. Then do the odds, so that's 0, so that's the first and the third, so the first and the third, we've already done the ends, so they're the ends, these are the odds, and these are the evens. So next one then, if we're going to do the odds, it's going to be x equals a quarter, so we get tan to the minus 1 of a quarter, and x equals 3/4, so we get tan to the minus 1 of 3/4, and these are the odds. And finally we'll deal with the even, which is x to the half. Now you may say, what about this one here? Well, we've already dealt with that one with the ends, so don't double count them. Make sure you've only used them once. So we get tan to the minus 1 of a half, and that's the evens. Now you can now plug that into your calculator and get an approximate answer, because you'll have to round up the answer. But I'd recommend you don't. You've got good calculators nowadays that can cope with this, so don't introduce any approximation errors. Just deal with these as they are written there. So now if we're going to integrate between 0 and 1 of tan to the minus 1 of x dx, that's going to be approximately equal to 1/3 of h. Now h is the width of my interval, which is a quarter, so it's 1/3 of a quarter, and then I'm going to times that by, now it's the whole of the ends plus 4 lots of the odds and I'm running out of space, so I'm going to write it underneath, but it's within the same square bracket, and it's going to be 2 lots of the evens. So we've got a third of h, the whole of the n's, 4 lot of the odds, and 2 lot of the evens. Now if you put that into your calculator carefully, you will get an approximate answer which you can then round to, and on this one it doesn't give you, it doesn't ask you, so it's up to you, but I would recommend giving it to 3 significant figures or something on that, of that order. So put it into your calculator now carefully and see if you get the correct answer. And I get the approximate answer, 0.439 to 3 significant figures. Now if you don't get that value, just double check that first of all that you are using the inverse tan function, not the tan function, and also check that your calculator is set up on radians, not degrees. Now on to question 3. So this is the second of the Simpsons Rules questions. We had to use Simpsons Rules with 4 intervals to find an approximation to log x dx between 2 and 7, and it's giving you answers to 2 decimal places, or give you answers to 2 decimal places. Okay, and then for part B we're going to use what we've learnt for part A to deduce an approximation to the integral between 2 and 7 of log of x to the power of 12, and we're integrating both times with respect to x. Now you'll notice the first part's worth 4 marks and the second part's worth 2 marks. So that's a kind of hint in an exam that there's something that we've done in the first part that's going to help us with the second part. But we'll get there in a minute. So let's start off by working out the values of x, or the ordinates that we're going to need. Well, we need 4 intervals. So 1, 2, 3, 4. So there's 4 intervals, and including the first number 2 in this case, not 0. Don't always put 0. Sometimes we don't integrate between 0 and something, so you have to be careful. And so we've got 5 ordinates including the first ordinate. So we're going to have to work out the other values of x in this case. So we know we've got x equals 2 and x equals 7, but what are the others? Well, unless you can see it immediately, so halfway between these 2 numbers is the mean of these 2 numbers. So it's going to be 9 over 2. 2 plus 7 divided by 2. And then the same here for the values between these 2 is the mean of these 2 numbers. And for this one it's the mean of these 2 numbers. So work out these 2 please. So pause your video, make sure you get the ordinates correct. So we've jumped the first hurdle, we found the 5 ordinates, and we've worked out its 4 intervals. Remember that the intervals when using Simpsons Rule must always be an even number, but on all the questions I've seen they've always told you how many you need. Remember, they're either going to tell you the intervals or ordinates. So now we're going to use the Simpsons Rule like we did last time. So let's deal with the n's first. So we've got x equals 2. We're going to substitute log of 2. And x equals 7. We're going to substitute log of 7. So there are n's. Now we're going to deal with the odds. X is 13 over 4. So we're going to do log of 13 over 4, and x is 23 over 4. We're going to do log of 23 over 4, and there are odds. And finally our even one in this case is 9 over 2. And again, be careful not to think that's even, we've already dealt with it as part of the n's. Now we're going to substitute it carefully into our approximation. So we're going to have a third of h. Now you need to work out h. So pause your video and work out h. Well, h is the difference between any, or the width of the interval, or the difference between any of those pairs of ordinates. So if you do 13 over 4, take away 2, you get 5 over 4. Now we're going to add now both of the n's. Now be careful that you use these values, not these values. So log 2 plus log 7. We're going to do 4 lots of the odds. Now remember, you can leave it in your calculators. Your calculators are excellent nowadays, so there's no need to simplify the answer at any point. or make it an approximate answer earlier than you need to. And then finally it's going to be 2 lots of the evens. So I've got a third of H, the whole of the n's, 4 lots of the odds, and 2 lots of the evens. And I'll carefully put that into my calculator, and I want you to do the same and see what answer you get. So pause the video. And you should get an approximate answer of 7.23 to 2 decimal places. Just check your calculator if you haven't done that, make sure you've substituted incorrectly. So the final part then is to use the value, use this answer to the first part to deduce an approximate answer to that. Well, that takes us back to our logarithm rules when we were in core 2. And we know that log of a to the power of b is the same as b lots of log a. So we can rewrite this integral as 12 lots of the integral between 2 and 7 of log x dx, which is approximately equal to 12 lots of 7.23, which you can work out with your calculator very quickly. As 2,169 over 25, or 86.76. Now it's only worth 2 marks, so you weren't expected to go off and do another full approximation like we did to part A. If you had done, you probably would have got the marks in the exam, but you just would have wasted time, and time is also important.